Hello students, this is the 8th lecture of the series on machine learning. We will cover these 4 topics in this lecture. So if this video helps you, please like it and subscribe to my channel. So let's start. Classification is one of the fundamental concepts in machine learning. It models the relationship between one or more predictor variables and one target variable. The predictor variable can be either numeric or categorical, but the target variable must be a categorical variable. The predictor variables are also called features. Now in case the target variable can have only two possible values, then this type of classification is called binary classification. For example, if we want to predict whether a person has heart disease or not, how many possible outcomes are there? Whether the person has disease or he does not have disease. Only two possible outcomes. Thus, this is an example of binary classification. In case of such type of classification, it is common to represent the two possible values of the target variable with 0 and 1. For example, we can use 0 to represent the person has no heart disease, and we can use 1 to represent that the person has heart disease. Now, in case the target variable has more than two possible values, then this type of classification is called multi-class classification. For example, if we have an image that contains a digit, but we do not know which digit it is, so we are using machine learning to find out which digit it is, to classify the digit. So in that case, how many possible outcomes are there? Because there are 10 possible digits from 0 to 9, this means that there are 10 possible values of the target variable, and that means that this is an example of multi-class classification. Let's say that we want to use a regression model for binary classification. So in binary classification, the target variable is a binary variable that can have only two possible values, which we can represent by a 0 and a 1. Whereas a regression model outputs a continuous numeric value, which is in the interval from negative infinity to infinity. So we want to convert the continuous output of the regression model into a binary output. That is, the output of the regression model is in this range, and we want to convert it into a value that is 0 or that is 1. One way to do that is to choose a threshold value. Let's call that t. Now, if the output of the regression model is greater than or equal to t, we can map it to a 1. And if that is smaller than t, then we can map it to a 0. T is called the threshold. Now, let's consider this equation of a regression model that takes in the age, the blood pressure, and the cholesterol level of a person and outputs a continuous value. Our target is to predict whether a person has heart disease or not. So, we can use this continuous value to predict a binary outcome for our classification task. How we can do that is we can set a threshold at t equals 0. If the output of this equation is greater than or equal to 0, we can say yes, the person does have heart disease. But if it is less than 0, we say that no, the person does not have heart disease. So I have written two examples here. The first example has these three values: age is 30, blood pressure is 100, cholesterol is 120. Once we put these three values in this equation, we will get the result minus 7.1. So our threshold is 0. We convert, we compare this value with our threshold. This value is less than threshold, less than 0. So we say no, the person does not have heart disease. This is another example. Age is 70, blood pressure is 160, cholesterol is 280. When we put these three values in the equation, we get y equals 1.9. Compare it with the threshold. Is it greater than the threshold? Yes. So that means that according to our threshold, the person does have heart disease. When applying thresholding, the output of the regression model can be any real number. Let y denote the output of the regression model. This y will belong to the interval negative infinity to positive infinity. This is a very big interval, and it is not feasible and not easy to interpret a value in this interval. We want to convert, we want to map a value in this interval to a much smaller interval. We want a function that takes as input a value in this interval and gives us a value in our desired interval. Our desired interval can be our own choice of interval, such as an interval from 0 to 1. We want to map all the values of y into this interval, or it can be an interval from -1 to 1, or anything. We can choose it according to our problem. So a function that converts a value from one interval range to another interval range is known as an activation function. It maps a continuous output to a desired range. A continuous output that is in this range from negative infinity to positive infinity and maps it to an output to our desired interval, which can be this interval or any other interval of our choice. Three commonly used activation functions are the sigmoid activation function, hyperbolic tangent activation function, and the rectified linear unit activation function. This is the equation of the sigmoid activation function. It is represented by the sigma sign. This is sigma, and it will take as input this y, apply this function and give the output. If we put in negative infinity, we will get sigmoid of negative infinity as 0. If we put here positive infinity, we will get a 1. If we put in here a 0, we will get a 0.5. So the sigmoid activation function will map this interval into this interval. Another commonly used activation function is the hyperbolic tangent activation function. This is the equation of the hyperbolic tangent activation function. If we put in here negative infinity, we get a minus 1. If we put here a 0, we get a 0. If we put in here a 1 with positive infinity, we get a 1. So the hyperbolic tangent activation function will map this interval into this interval. The third type of activation function is the rectified linear unit activation function. What it does is simply it will convert every value less than 0 into a 0, and any value greater than 0 will remain the same. So the third type is rectified linear unit activation function. There are many other activation functions. If we are using the sigmoid activation function, it is common to use the threshold of 0.5. If we are using the hyperbolic tangent activation function, it is common to use a threshold of 0. If we are using the rectified linear unit activation function, it is not commonly used for thresholding. It is simply used when we are willing to discard the negative outputs of the model. Decision boundary is a line or a curve that divides a data set into two categories. Suppose we are doing binary classification using a data set of two predictor variables, which are x1 and x2. So first of all, we plot both predictor variables, one on the horizontal x-axis, the other one on the vertical y-axis. So when we plot the data, these are the points present in the data set. After that, we have this blue line here. This blue line acts as the decision boundary. All the points on one side of the decision boundary are the red points that belong to one class, and the points on the other side belong to the green class. Now in this example, there are two predictor variables. So the plot is two-dimensional, and the decision boundary is a line. A line is one-dimensional. So the decision boundary is one-dimensional. If, for example, we had a third predictor variable x3, where would we plot this? We would need a third axis, a third z-axis, perpendicular to both these axes. So in that case, the plot would become three-dimensional, and the decision boundary, then it would not be a line, it would become a two-dimensional plane. A two-dimensional plane. Now if we have another predictor variable, which is x4, then the plot would become four-dimensional. There is one dimension for each predictor variable. So with four predictor variables, the plot is four-dimensional, and in this case, the decision boundary would become three-dimensional. So if we generalize it, if the plot is n-dimensional, the decision boundary is n minus one dimensional. This plot here, this is called the feature space. Feature space. And this decision boundary is called the hyperspace. The hyperspace.